Hello everyone and welcome to our channel. Today, we are going to unravel one of Java's most powerful and fascinating features, the Java Reflection Application Programming Interface. Have you ever wondered how some frameworks can magically inspect your code, create objects, or call methods without knowing their names beforehand? Well, the secret lies in reflection. It allows a running Java program to examine or modify its own behavior at runtime. This means you can inspect classes, interfaces, fields, and methods, and even invoke methods or create new instances dynamically. By the end of this tutorial, you will have a solid understanding of what Java Reflection is, why it's useful, and how to use its core components in your own projects. Let's dive in. Our journey into reflection begins with the class object. Think of the class object as a blueprint or a metadata container for any type in Java. Every time you define a class, the Java Virtual Machine, or JVM, creates a class object that describes it. To use reflection, your first step is always to obtain this class object. There are three primary ways to do this. First, using the .class literal, like string.cls. Second, by calling the getClass method on an existing object, for example, myObject.getClass. And third, using class.forName, com.example.myClass, which is useful when you only have the class name as a string. Let's see these in action with some simple code examples. Once you have a class object, you can start peeking inside it to discover its members, such as fields and methods. Imagine you have a locked box, and the class object is the key. Now you want to see what's inside. To get information about the fields, you can use methods like getDeclaredFields, which returns an array of field objects representing all declared fields of the class, including private ones. Similarly, to inspect methods, you use getDeclaredMethods, which gives you an array of method objects. Each field object provides details like the field's name, type, and modifiers. Each method object gives you the method's name, return type, parameters, and so on. This allows you to programmatically understand the structure of any class. Now for the exciting part, not just inspecting, but actually interacting with the class dynamically. Let's say you want to invoke a method whose name you only know at runtime. Reflection makes this possible. First, you need an instance of the class. Then, you obtain the method object for the specific method you want to call using getDeclaredMethod, providing its name and parameter types. Finally, you use the invoke method on the method object, passing the object instance on which to invoke the method and any arguments it requires. This is incredibly powerful for building flexible applications, like frameworks that execute user-defined logic or serialization libraries. Let's see a complete example of how to dynamically create an object and call a method on it. While Java Reflection is powerful, it comes with its own set of considerations and potential pitfalls. One common mistake is forgetting to handle exceptions like class-not-found exception when using class.forName, or no such method exception and no such field exception if the method or field name or signature doesn't match. Another important point is security. By default, you cannot access private fields or methods using reflection. If you try, you will get an illegal access exception. To overcome this, you must explicitly call setAccessible true on the field or method object. However, use this with caution, as it bypasses Java's access control mechanisms. Also, reflection operations are generally slower than direct method calls, so avoid using them in performance-critical sections of your code. Use reflection judiciously, primarily for frameworks or tools, not for everyday application logic. Alright, we've covered a lot today. Let's quickly recap the key takeaways from our Java reflection journey. We learned that reflection allows us to inspect and modify classes, fields, and methods at runtime. The class object is your starting point, obtained via .class, getClass, or class.forName. From the class object, you can get field and method objects to examine their properties. Most importantly, we saw how to dynamically create instances and invoke methods using newInstance and invoke. Remember to handle exceptions and be mindful of performance and security implications, especially when using setAccessible true. Reflection is a powerful tool that opens up many possibilities for building flexible and extensible Java applications. Keep practicing these concepts, and you will master them in no time. If you found this tutorial helpful, please give it a thumbs up, share it with your friends, and subscribe to our channel for more exciting Java content. Happy coding!